Hey guys, what's up? So this video is brought to you by Dev Mountain Coding Bootcamp. If you guys are trying to get into software development, iOS development, software QA, and other stuff, check out the link in the description tab below. They are offering courses. You can actually live on campus over there. They are hooked up with employers around the country, around the world really, and they're going to help you try to find your first job in this industry. So make sure you give them a look, Dev Mountain Coding Bootcamp, and the link is in the description tab below. Hey guys, what's up? Good evening. Welcome on this Rust journey. This is going to be about getting started with Rust. So a lot of people are like, well, why do you want to learn it? It's a really fast language. It's going to compete with C++. So Rust is built with concurrency in mind. So it's built for being able to scale parallel systems and things like that. So everything is immutable by default, meaning that all your variables, they cannot be changed after you declare them and give them a value. There's ways around that, but by default, it's designed that way so that it can actually scale very well, especially across multiple processors, parallelism and concurrency. This particular example right here was written in Rust, and Rust using different game engines that are already ported and available right now. But then they compiled it to something called WASM, which is WebAssembly, and that is actually being used to run inside the browser. So that's actually a brand new thing that's come to the browsers. And just the last few years, but both Rust and C++ are great for building games that run in the browser right now. So Rust was actually started almost, actually 8 years ago now by the people over at Mozilla who created Firefox. And they just really made it to be an easier way of getting closer to the hardware to get the true power and speed that you need. So Rust is going to be much, much faster than something like Python, JavaScript, C#, Java, any sort of language like that. Rust is much faster. It's going to compete on a systems level language with things like C and C++. And it's great for video games, for like web servers, chat clients, all kinds of different stuff. All right, so to get Rust installed on your machine, you need to go to rustlang.org, and there's going to be a bunch of different install options that you have, but since I'm on Windows, I'm going to use the executable, but it has installation instructions for whether it works on Mac, Windows, and Linux. All right, so when you get prompted with this message here, you just want to do one for the normal installation, press enter, and then Rust is installed. It's as easy as that. All right, so if everything is installed correctly, you should be able to go to a terminal or to your command prompt on Windows, and you should be able to type something called cargo. Cargo is the package manager for Rust. So if you've ever done Python development, then pip is what cargo is to Rust. And if you've ever done like Node, then npm is the same thing as cargo. So if you wanted to run the Rust just to see what version you have, you can type version after typing Rust C, and this should tell you the version number. Now keep in mind that I have the nightly build enabled, and that's actually something that you're going to want to have enabled if you want to have some of the cutting edge. Like if you want to use all the latest packages, then you want to have the nightly version. So if you do not have the nightly version enabled, then you can actually do that by saying rust up and then just say default nightly. And then you can see it's changed. So, well, mine's still the same, but whatever. Yeah, I think it's the same. Yeah, it's the same thing. Alright guys, so to get started coding with Rust, what I recommend is that you download Visual Studio Code because it's a free editor, it's cross-platform, and it has all the available tools that you need. So when you go to your extensions over here, if you type in Rust, you're going to want to make sure that you have the Rust RLS tool installed. And I also have this extension as well. So the top two Rust results, make sure you have those installed. You can see, because they have respectfully 500,000 downloads and 125,000 downloads. That's a lot for a community that's not nearly as large as something like Python. So what I'm going to do is I have a tutorial folder that I'm going to open Visual Studio to. It's just called Rust. And we're going to have a few different projects in here that I want to show you. But the first thing we're going to do is just have our, we'll just call it hello. So we want to have a folder in here called hello. And then we're going to create a file called main.rs, which is a Rust file. You can see that this says the RLS is not installed. So let me go ahead and install this. I'm not sure why. And I'll update it as well. So earlier I said about the extension. I actually take that back. I think you guys should just have this extension installed because otherwise I think they compete for each other. But every Rust program should have a main file, like a starting point, and it should have a main function. To declare a function, it's going to be the fn keyword for Rust, and then it's going to be the main keyword, which is the start. And then if you want to print something to the screen, you're just going to say print line. And then you have to use this exclamation mark. It's kind of weird. And then we're going to say hello Rust. All right, and then every statement in Rust should be terminated with a semicolon. It is a semicolon type of language. All right, so to see this bad boy in action, if we want to go ahead and build this, we're going to go ahead and right click and say open in terminal. And then I'm going to say Rust C. And then we just simply say the name of the file that we want to compile, which is main.rs. And this is going to go ahead and create an executable file. So if I just double click on it, I'm not going to be able to run it from here, but I can go ahead and just run the main.exe and you can see we get hello Rust. So that executable file, you could actually just, or you could just, as long as you have the libraries and everything with the executable, you could go ahead and distribute Rust and it's just going to run. It runs natively on whatever machine, machines that Rust supports. All right, in order to create a new Rust project, what we want to do is actually use Cargo. So Cargo gives us the ability to create the right format that a Rust project should be structured in order for us to be able to have dependencies so that we can actually bring in other projects and things like that. From within our project here, I'm going to say open in terminal, and we're going to use Cargo to create the new project, and we're just going to call it hello. We'll just say first. All right, so now we create this first project here. I gotta get rid of hello here. That's not supposed to be there anyway. So now we have this first here, and what you want to look at here is that every Rust project should have a source folder, and that is the source of your project is going to be situated. And then the cargo.toml file here. This is the it's very similar to something like a package.json if you've ever done Node.js, but it's going to keep track of all your dependencies. So we can require dependencies of like entire game engines and things like that we'll see. And you could just easily list it as a dependency, and Cargo is going to be smart enough to install that. So in order to see how Cargo is actually going to compile this project, let's go ahead and cd into the project here. And then what we're going to do is say Cargo run build. All right, so this is going to create a target folder, and this is the actual output folder that you want to then distribute. Inside the debug folder, you can see this is where we have the actual everything you need to distribute. The first.exe is located there. So if I just for right now, I'll just open in the terminal, and then we can go ahead and run that. Just say first. You can get the hello world. Again, this is all kind of the roundabout way. There are tools available in Visual Studio. Again, I'm not trying to lose, I don't want to lose anybody by trying to install tools for Rust that may or may not work, because Rust is a very new language, and some of these tools for Visual Studio Code are still a little bit buggy, so I don't want to lose you guys. But this is like ultimately the roundabout way. You want to fire off that program that just got created for you, cd into the debug folder, and then run the program, the executable. And you can see the output of it. But you can see that's how we create a project with Cargo, and then that's how we build the project with Cargo. And then you saw how we actually ran the outputted project that runs natively on my Windows machine. But if you're on Mac or Linux, it runs the same way. All right, so in the previous video, I showed you how to build a project with Rust, and in this video, I just want to show you how to actually run the project much faster. If you want to just get the output, you can just, let's open up in the terminal, And you could just simply say cargo run. And by saying cargo run, it's actually going to build and then do the output. So now when we start changing values, and we press Control S to save it, and we do Control Run, or we run it, then we get the output. You don't have to do the build and then try to find the executable and all that stuff. It automatically executes the executable. All right, guys, let's go ahead and look at immutability and what that means in Rust. So Rust tries to pound home the fact that when you declare a variable and a type and a value, that you can't actually change it. So to declare a variable in Rust, we use the let keyword. So that's very similar now to the latest version of JavaScript, which makes things pretty easy. So if we change, or if we allow x to be equal to 1, we can terminate the statement using the semicolon here. And then if we want to actually print the value, we can go ahead and say the value of x is, and then here we'll go ahead and put in these curly braces. This curly brace is basically saying we're going to go ahead and accept the first argument here is going to be x. So we're going to make use of our x, so we're going to pass it in to this statement, and we're going to see how we can actually print this type. All right, so let's do the cargo run, and then you can see the value of x is 1. All right, guys, so Rust has basically 4 main types, and x here is going to be assigned the value of 1, and that is the number type. So Rust has 4 what they call scalar types, and the scalar types are representative of a single value. There's 4 of them. There's integer. This is what you're looking at here. Then there's floating point numbers when you need to have more precision, and then there's booleans for boolean logic like true, false. And then you have characters, which are string values like what you see here. So those are like the 4 main types that you're going to see. But then there's different types of integers in Rust, because Rust, you can declare numbers that can be very small or very, very large. But it's all about memory efficiency and things like that. So if you don't need a large number, you're going to use something like an 8-bit signed variable or something like that, or signed integer. So if you guys are concerned, and this isn't a beginner level programming, in fact, I would not recommend Rust probably for absolute beginners, because it's definitely a more systems level hardcore language than something like Python. But with Rust, though, like an integer, the difference between an integer and a floating point number is obviously a floating point number can have fractions, decimal places, and things like that, where an integer is going to be a large whole number, right? All right, so again, let's look at this. We're going to put the comment. If you want to put a comment in Rust code, it's going to be the / convention. We're going to say let y equals 2.0. So this is going to be a floating point number with fractal precision. All right, so one thing I want to show you real quick is that every statement in Rust needs to be terminated with a semicolon. If we were to try to compile this right now, we would end up getting an error message because every statement needs to have a semicolon. But now what we can do is we can actually try to run this. But what's going to happen is Rust is built with immutability in mind for concurrency, which means that once variables are declared, you can't change them. We'll see that example in just a second. But in addition to that, it also complains if you try to run a program or compile a program and you have unused variables, like variables set aside by the program that are never used, and it just takes up memory and things like that, that on an end user's machine that is just never used. So Rust won't even let you compile the program. In this example, you can see y is being declared as a floating point number, but we're not using it in our program anywhere. So if I were to compile this, then we're going to end up getting this. We're still going to get the value here that doesn't complain, but it does say that there's this warning here, this unused variables. And you could turn this off, but this is actually just warning to let you know. You could actually set it up so it doesn't compile. In this case, it actually does compile by default. That's new to me. I thought that it didn't do that. But anyway, this is just a warning actually being fired right here. But you could set it up to where it wouldn't compile for unused variables, and that's probably what you should do. If we wanted to see like an error message, you can see like if we didn't terminate this statement right here, and we go to try to run it, then we're going to get this unexpected token, and Rust will warn you of different error messages. So this is the difference between an error message and an actual warning. All right, so the other types we have are let Chris equal, Chris is a string value. So we've declared Chris that is a string or character type. All right, so that's the character type. That's just basically like any other string. And then finally we have our Boolean, which could equal true or false. Boolean. All right, so those are like basically the 4 scalar types that are in Rust, and that's what they try to pound home. You're going to see that a lot. You're going to see different integer types as far as the different int values, like unsigned and signed integers up to like 32-bit, 64-bit, things like that. All right, so Rust also has the ability to do basic like math. So you can look at like let dynamic math equals 8 times 8, right? So terminate that, and then we'll go ahead and reference this. All right, and then you get the value x equals 64. So just like other languages, if we wanted to do something like 8 minus 2 plus 8, you could actually do that as well. It's going to follow the same conventions, so the same mathematical conventions like math multiplication and division is going to be treated with greater precedence, obviously, than math or addition or subtraction. And if we run this program, you can see you can get that dynamic output there. So you could see with division, it's going to be like just /. So anyway, that is like the basics. Again, this isn't a basic programming sort of thing, but those are, you have all the basic math computations at your disposal when you're dealing with Rust and types. All right, some of the other data types real quick. You have the array. So if I wanted my array, I could say it equals, and it's going to use the square brackets, very similar to like a Python list or even JavaScript array. So that's how you declare an array. And they also have tuples in Rust. So tuples use very similar to Python. So I could say let my tuple equal, and it's open and closing parentheses. And then inside of here, you can go ahead and just declare whatever sort of values you want in here. So I can go ahead and just fill in these values like right here. So, and it can actually hold different types too. So I can have like 5 and then 5.0 for floating point number. And then we could even put a string of characters in here. So we'll put Chris in here. All right, so that's the tuple type. And what's cool about this is we can go ahead and declare actually a few variables if we wanted to. We could actually say let dynamic x, dynamic y, and dynamic z, and then we'll say it equals the values of my tuple. And then this is using a tuple to create variables on the fly. All right. Anyway, so that hopefully you guys can see what's going on there. So now if I want to actually reference one of these, I can go ahead and just say like dynamic z is going to be Chris. So if I wanted to see that in action, I can say cargo run. You can see the value of x is now Chris. So tuples, you can see, you can get the, you could see the quick custom variable generation that can happen on the fly. All right, so very similar to other languages. If I wanted to look at a array and I needed to get a certain value from that array, I could actually pass in the index value. So if I pass in my array of 5, you can get that I get 6. So it counts at 0. So 0, 1, 2, 3, 4, and 5. And that's why it comes back with 6. How's that for a MindF? I'm just kidding. Most programmers are actually very used to counting at 0. All right, guys, so that's basically it with types. I'm not going to get any more boring than that. There's so many different tutorial series out there where they'll spend an hour on types and stuff like that. You guys don't need to know it. You just need to know how to look at it and figure out what it is. I think this does a good enough job, and let's go ahead and move on to more better stuff. All right, guys, so let's go ahead and take a look at functions. Obviously, we've already looked at the function main, and we've seen that that's how you can declare a function with the fn keyword. And it's as simple as that. So I could just simply say fn hello world, and you just have to have the same naming convention as normal variables. So you can't be like doing something crazy like having some numbers on the front. Don't be doing that. Don't be doing that. I'm just kidding. But anyway, you can't do that on your variable names or your function names. But here we could just simply do like a print line, hello your mom. All right, so now when we go ahead and call this, we can just simply reference the hello world, and you can see it automatically fills it in for me and calls it as a function. So you use the open and close parenthesis to call the function as a function. And if we run it, you can get hello your mom. All right, so you can have as many functions as you want, and functions can actually take in an argument. So we can actually say, you know what, I want this to go ahead and take in some sort of value, right? Like a string, or like a string value. All right, so functions can be a lot more dynamic. They can actually take in like string values. So this could actually say something more dynamic where it says, you know what, we're going to accept an argument, and we're going to use the curly braces, open and closing curly braces, followed by whatever sort of argument we plan to pass in. So we'll just call this x. You know what, we'll just call this name. Let's make it more descriptive. And then this function can actually take in an argument called name, but you have to declare what type of value it's going to take in. So this is a string value. But what I want to show you is this is going to result in an error message, because even though we can pass in a value like Chris, this is going to complain because it doesn't know how large the string value should be. And there's a shorthand convention in Rust that we'll see here, but when we say, let me show you here. All right, so this here, you can see that it complains, and it says that, hey, it doesn't have a size known at compile time. So the shorthand way around that to have it dynamically figured out is to use the and symbol along with the string, and it will dynamically interpret how large it should be. You could see that we start getting the value, and this is now a dynamic function that you could pass in an argument and then get a value. All right, so now this is if we want to have an add function, this is where you have to be a little bit more explicit about the type of value that you expect to pass in. So if we're taking in two integers, we could just say x, and we want to declare how large it should be. So if it's a very small number, you could just use, you know, an 8-bit number. That should be fine. And then y will be the same thing, an i8. All right, and then this will just simply print line, you know, x plus y. All right, and then we can go ahead and call that, and we'll give it two very small numbers, 5 and 5. And hopefully you guys know what the output of that's going to be. And that's going to be a typo. Oh, because, I'm sorry. Yeah, my bad. All right, so we need to actually put this in a string because this is going to be an argument. It needs to coerce the mathematical computation into a string, and that's why, because print line is actually a string to the console, so it needs to take a number, turn it to a string, and that's why by convention you have to do that. But now you can actually get the output, and hopefully you guys knew 5 plus 5 is 10, unless you don't have 10 digits. I knew a girl with 12 toes one time. All right, guys, functions are boring me. Let's move on to something else. All right, so you guys want to be hardcore Rust programmers to build games and stuff like that. You're not going to be able to do it with functions and types and values, right? Actually, that's exactly how you do it. And you have to start off with that boring crap, and nobody cares about all that stuff. Let's go ahead and remove all this. We do want to have a function main, actually. We do want to have a main in here. And for right now, main won't do anything. But let's go ahead and in our TOML file, this is where we're going to add our first dependency. We're going to do something called it's Piston window. It's a Piston game engine for Rust. So anyway, we're going to say, you know what, we need to use Piston window, and you just spell out the version you want. You can give it an actual version number, or you can use this star, which says just go ahead and get the latest version. All right, so here what we're going to do, we're going to go ahead and I'm just going to show you an example of like how to draw a red box to the screen using this project here, and we're going to copy and paste this entire thing. And this is a little bit complicated here, and essentially here though, this is the Piston library, and the example that I'm trying to show you guys is how to actually install a dependency, and not necessarily exactly how some of this functionality works, especially some of the module importing and things like that we haven't looked into. But pay no attention to that. This is where you're going to be drawing the red rectangle, putting the output to the screen. This is where you're writing it. So it's a game engine. So basically, this says exit on escape equals true. So if we press escape, we're going to be able to bounce out of it. This is setting the actual screen size to the game. But overall, it's a relatively small amount of code here that you can see that we're using. Now, if we want to go ahead and run it, we can say cargo run. Now, this is going to be smart enough to know that, okay, now we have this dependency. We need to go ahead and download all this stuff that this dependency needs. And since it's a game engine, it's going to have a relatively large amount of dependencies that it needs. And yeah, so it's going to download a lot. All right, so now when everything's said and done, we now have this actual working executable game, and now it only just shows a square to the screen, so obviously not that complex or anything, but it's still pretty cool. You just created that with Rust with very little effort. All right, so if we want to actually get started with using the standard library that comes with Rust, we can actually do that to create a web server relatively quickly. So at the top of our project, to make use of a module, especially from the standard library, you're going to use the STD, which is really a terrible abbreviation because it stands for sexually transmitted disease in most people's minds. But anyway, standard library here. So then we're going to say use net and then use the TCP listener. You can see you get some IntelliSense here, but this is how we actually can now use this inside of our program. So let's go ahead and create our main function. And then inside of here, let's go ahead and create a web server using that. We're going to say use the TCP listener that we just imported. And then we want to use the bind method from that project. So you use this double semicolon convention to find the method that you're then calling on that library. And this is where we can say, go ahead and give me the localhost address to use. We're going to do 8000. That's my port from my Django days. And then we're going to say unwrap and call that as a function. All right, now we need to go ahead and say for stream. This is where we're looping over the stream and the data that the listener is returning to us. So we're saying listener.incoming. So that's the stream that the listener is giving to us. And then we're going to create a stream variable. And we're going to say that it equals stream.unwrap. All right, and then we're going to go ahead and say print line. And this is where we say started our, we'll just say a connection was made. All right, there we go. And then terminate that with a semicolon. All right, that's our program. So we're going to say cargo run. All right, so now this thing's going to be running. Now, if we go to our localhost address, let me go ahead and put that in here. And I actually navigate to it. You can see now when we go to it, every time we make a request to the server, it's just a single threaded server. But just like that, we were able to take Rust and create an actual web server. Now, clearly, a web server needs to do much, much more than that. It needs to determine MIME types and read connection header requests and things like that. But Rust is all about the lower level bits of all that stuff. So you could actually make your own web server in Rust that is literally executing Python code on Apache or something like that. It just, there's all kinds of different stuff you could do. Rust is a systems level language. It makes really, you're going to be able to build whatever you want with it. But it's very low level in the sense that we've already seen that, you know, that it could be very picky with integer types, things like that. But with just a little bit of code, we were able to import things like the standard library, get a basic web server up and running, or at least something listening on an actual port. So that's pretty cool.